to the OKD Community Development Meeting for June 13th, 2023. And we are going to focus today on operators and catalogs of operators and sort of understanding what we need to do to get into the right place to have the OKD specific catalog and start populating that with operators that folks are looking for. So the first thing that I think we should do is, and Brian, if you think otherwise, let me know, but I was thinking that we start with the basic, so everyone is on the same page, have a discussion about sort of what is the catalog and where are the resources to understand how catalogs are built. And we've got a couple of folks on the call that are familiar with that. Christian and Kevin, I think you know a little bit about it. And so that seems like a good place to start. Brian, does that seem about right?
Yeah. I think it might just be worth just winding back one more step and saying what we're trying to do here is add some of the key operators to OKD so you can do an install without having to get a Red Hat entitlement key or in the activation key. So you can install a pure open source version of OKD, and we want to provide a catalog that will replace the Red Hat catalog that comes with OCP, where it is a catalog, an open source catalog, again, no entitlement keys needed, to go into OKD to add some of the core features. And some of the ones that we're talking about are things like the pipelines, the GitOps. There's a few that we've identified we see as mission critical operators that you can't currently get unless you get an activation key from Red Hat to add the Red Hat catalog, or you actually work out how to install the open source versions from the open source catalogs. So that's the goal here, that we will provide a catalog that will come into, we create a catalog source in OKD, and that would then provide some of these key catalog operators. So I think that's what we're trying to do. And yes, I think now is a good time to actually just go and do a level set on what an operator is, what an operator catalog is, and the resources we need to do that.
Yeah, so who wants to tackle operators just to provide any, and this is also, I should add, not geared just towards the attendees at the meeting, but think about there are folks that watch the videos after the fact once they're posted. So we are trying to really sort of provide a base level understanding of this all. So who wants to chip in with operators, basic explanation of operators?
Well, we've got Kevin Ritzer here, who's on the OLM team, and he's like the domain expert. So Kevin, if you don't mind kicking off and giving us the whole rundown on operators, if that's okay.
Yeah, that's fair. So hi everybody, I'm Kevin. This is my first time on this call. So I'm one of the developers on the Operator Framework project. If I was to summarize at a very high level what an operator is, it's essentially a pattern used to define an application that runs in a cloud native way on a Kubernetes cluster that uses the same pattern that Kubernetes itself, so the API server and how it defines objects, to extend the Kubernetes control plane to allow you to define arbitrary resource types. So basically you can build an app that speaks Kube natively. And it uses that by, like I said, using the Kubernetes controller pattern and the CRD API.
Fantastic. All right, and now let's move on to how does a catalog fit into all this? Maybe Kevin, you can take that.
Yeah, sure. So the metaphor I like to talk about frequently is so there's kind of two main parts to the operator framework, right? There's the operator SDK, which is kind of a project that allows you to bootstrap and scaffold and build operators, which is a wrapper around a community effort called controller runtime. And then there's OLM, which is what I kind of like to refer to as a package manager for Kubernetes operators. And so the catalogs that we're discussing here are really, think of them as repositories for content that wants to be distributed in some way. So with the operator framework, often the metaphor we like to use is, if you're familiar with the concept of a Yum repository or repos in apt-get, you can consider the metadata for a specific operator, which we call an operator bundle, to be kind of like an RPM. And then the catalog is kind of like the Yum repository. It's a collection of packages that you can present to a cluster so they can be installed by users on the cluster.
Excellent. And for clarity, can catalogs be layered? Can you have multiple catalogs installed at the same time? Or is it one at a time, or?
Yeah, so you can. So there's actually the catalog source API, which is part of the operator lifecycle manager, allows you to define not just multiple catalogs, but also the scope of where that catalog is available, right? So generally, if you create a catalog in a specific namespace, then the content available for that catalog to install on the cluster is scoped specifically to that namespace.
Any questions on any of that that's been mentioned so far? Any feedback, any thoughts, anything to add to that? All right, let me throw now to Christian, if I could. Christian, can you explain a little bit about OKD's catalog setup and the creation and configuration of OKD's current catalog?
So if I remember correctly, we definitely disable the Red Hat catalog source by default. So you can still re-enable it. That's actually the default build setting for that operator in OKD to have it enabled. Well, we disable it, and then instead additionally, we enable the community operators catalog, which contains the upstream operators of things like Tecton and Argo CD, and a lot of other things. But I think what the goal with the OKD specific catalog is in cases like this, and maybe we could even publish our operators to the community operators catalog too, if they're okay with it. It's just not going to be, not going to be working on any kind of standard Kubernetes cluster. But really, what the catalog does is provide the operators, and they can, as I understand it, even conflict with each other on the same resource. But what we want to do with the OKD builds is have the OKD optional operators, which are OLM operators, which have specific integrations with OKD and OpenShift tooling and machinery. We want these builds for OKD. And we don't want, for example, the upstream Tecton operator on an OKD cluster, because we could have the operator with more integration, and that actually shows up on the console, even though I think the upstream operator does that too. But there's more integration, I think, especially with the GitOps operator, which bundles a few things, not just Argo CD. There's a couple of controllers within that one operator for different resources.
Christian, I think it's also worth mentioning, if I remember correctly, that the community catalog on OKD is actually the one built for OCP. So it actually has some links into the Red Hat catalog. So for example, you can't put the Che operator from the community because it wants the dev spaces or dev file from the Red Hat catalog. So that's not purely the operator hub catalog. That is a community catalog that's been built for OCP that's shipped with OKD, I think.
Right, right. And then we don't actually have the upstream operator, the community operators catalog, which I linked. That isn't. Yeah, sorry. I remember there was something with that. Yeah, we do have that special community thing, but those are really just operators that are meant for OpenShift, but not officially supported by Red Hat. But yeah, I mean, ideally those would work with OKD too, but I guess that in the community catalog, in that one, I don't think we have Tecton at all, for example, because that has been moved from that community catalog into the Red Hat subscription catalog, and is no longer available on the Red Hat community one. So yeah, in order to make that available to OKD users, I think, and I think the group agrees that we should rebuild them ourselves, and yeah, hopefully we can learn some things from the experts like Kevin on the call today. Kind of any best practices for creating a bundle and adding it to a catalog. How would I create an empty catalog and add my first operator bundle to it? Would be my question to get started, maybe.
Great. Any other additions to the sort of foundational that foundational information? Anything that folks want to add or ask to get clarification?
What maybe from a development perspective, and I'm just asking, would we want to be able to, like Kevin did mention, the operator SDK? Would we want to mention that you could develop and build from scratch an operator, develop it and use it within the OKD environment, and then build it and use it and publish it in this, whatever we're going to use, this open source operator catalog? Are we also going to address that, or would that be a complete different topic?
I think personally, I think that's a great sort of in for people to use OKD, is to use it as a platform for developing operators and getting them into the catalog, and so they can see the results of their work and make that work available to the community. I don't know, what do other folks think? Is that within the scope of where we want to go?
So I think ideally we could build some kind of pipeline that automates these builds for us. And there is actually, I just put a link in the chat. There is actually a new operator built by Red Hatters that is now an internal preview for Red Hatters internally. And that is meant to replace the build system for the productized operators eventually. So it's an operator that essentially creates Tecton pipeline runs on demand and with additional smarts to it to build. Well, one of the artifacts it can build is operator bundles. And internally, we have the system called CPaaS, which Luigi and Shireen have a lot of experience with, I think. And the goal for that Red Hat App Studio thing is to internally replace that old build system for the productized operator bundle releases. So it is, maybe that's a bit too far out, and that Red Hat App Studio thing isn't production ready yet. We have an internal preview. It's usable internally now. People are starting to use it. We have a presentation about it internally that we can see and get some testimonials and see how it works. And to me, it looks really promising. They don't have multi-arch image build support yet, but that is coming this year. And so maybe that is something that is worth investigating, deploying this thing, because it has all kinds of niceties like GitHub integration and bot integration with Tekton. So maybe if we could stand up our own instance of that and use that to automate the builds of operators, that might, that might be nice. And that thing is an operator itself too. So that's where it closes the loop. But yeah, just kind of because that was just announced internally to us, and as it's open source, and I was immediately interested in using that within OKD to maybe eventually replace the other build system we have internally for building OpenShift payloads. This thing builds images too, so we could maybe use it to build OKD payloads with it eventually. But I think operators that's what it's meant to do internally for us, and so that's a much better target to get started with, I think. So if anybody's interested in kind of how we set up a system, and soon hopefully we'll have a cluster on the Massachusetts Open Cloud to actually deploy this on. That might be of interest to some of you folks here.
Excellent. Thank you, Christian. That's very helpful. Anything else on fundamentals? Anything else on fundamentals?
I think it might just be worth while just talking about what gets created. So how is an operator delivered, and what actually does a catalog contain? Because when I started this, I think that was something that it took a little bit of digging into the operator framework just to understand the relationship between an individual operator and multiple versions of an individual operator, the OLM and how it sort of managed the operator, and then how the catalog sat on top of everything. And everything is sort of delivered as a container within a registry. So, because at the end of the day, that's what we're going to get to. We have to create these tasks to take the source code for, say, a Red Hat operator, build the actual operator, and then work out how to add that specific operator version into the catalog, and how is that managed across multiple Git repos. So I think that's where we need to get to and try and understand how everything fits together. So
Kevin, can we throw to you on that to give us the process there?
I'll try to be as succinct as possible, because I think there's a simple version of this, and then there's a bunch of caveats that I need to add after the fact. So, at a really high level, let's start from the top down. So, a catalog. A catalog is a container image that contains two things. One is a binary that allows that catalog to actually run on the cluster. It's basically a server that exposes an API so that OLM can query and find out what data the catalog actually has. And then the second thing that container image has is a basically metadata repository of, here are all of the operators that can be installed from this catalog. Here is the metadata about how to install them. So that's the top level thing. Below that, there is the concept of the bundle image. So for each version of every operator, right, the catalog itself is actually just a bunch of pointers. All it has is the metadata about how to install. It doesn't have the cube YAML inside of it to actually install the operators. That's what the bundle image is. So for each version of an operator, there's another image. And that image purely exists as a repository for two things. One is some metadata about that operator, like what version is it? What is the name of the operator? Things like that. And then the second thing that it has is the actual Kubernetes manifests that you need to apply to the cluster to run that version of the operator. So the So so the catalog image is a collection of pointers to all of those bundle images. None of that is the actual operator source code. So the third thing that you actually need is right, because it's a thing that runs on Kubernetes, it's a container image generally, is the actual image of the operator controller, which is the software. Usually it's written in Go, although there's some other different options. Anything that can speak cube, you can write an operator for it. You need an image for that operator itself, and that thing has to be referenced by that bundle image. So in total, if you wanted to have a catalog with one operator in it, there would be a total of 3 images: the catalog image, the bundle image, and the actual operator image. So that's at a high level how it should work. In reality, there's some more complexity, and I'm going to throw this up there very quickly just so everyone's aware, which is a lot of operators are actually software that manages life cycle of some piece of software that is not Kubernetes native, right? You can imagine like a database operator. Usually the operator knows how to deploy one or some set of software onto the cluster as a container image. So like for the Postgres operator, as a trivial example, there's also going to most likely be another container image or multiple other container images that the operator itself knows how to deploy. And all of that is completely abstracted from OLM. So if you've ever heard, there's a phrase that references this called related images. It's basically some other metadata that we use so we can define, here's all the other images that you may or may not need through the course of actually like interacting with this operator's APIs. So that's in totality the set of potential container images, I think, that you could be concerned with when deploying an operator. In my opinion, and I think this is actually probably important, is that you want to, like whatever we're going to build here, we probably want to separate the problem space of how do I build the operator source code and all of the related images that exist as part of running that operator from the metadata build. Because really that metadata, the fact that it's a container image is not really important, right? We're using container images because they're a convenient tool that scales pretty well to get lots of data from lots of different places. You technically don't need to do that. There's some other bits that exist in OLM. At one point, we built something called App Registry that's been mostly deprecated since then, but was another store for that metadata that just didn't scale particularly well. So I feel pretty strongly that like whatever we do to build, and there's actually an example of this. If you've ever seen the Operator Hub, there's this upstream open source project that works, that's aimed at plain vanilla Kubernetes clusters, that has a project that builds catalogs. And that's all it does, is it builds catalogs and bundle images. And in order for that to actually work, all of the other images related to the actual operator itself are built elsewhere beforehand, before you ever interact with that project.
That's extremely helpful. Thank you so much for that. It's really great, Kevin.
And I think the last piece, Kevin, if you can just talk about update channels and update paths, because I think it's important to realize that once an operator gets into a catalog, we need not to strand somebody at a specific version, just like the actual platform itself. And there should be paths forward. And I think OLM manages that as well, doesn't it?
Yeah, that's correct. So a core concept for OLM is it's chiefly concerned with the life cycle of operators and making sure that they upgrade successfully. That's a big reason why, like, if you why use OLM instead of just writing a Helm chart, is because of this concept of upgrade. So attached to the CSV API, which is basically the wrapper OLM uses to define a lot of the metadata for the operator itself, is graph metadata. So there's this concept of the replaces chain. Basically, OLM for each operator understands the context of an upgrade graph for that operator so that you can jump from one version to the next. And it has a lot of features, so you can do things like if you want to skip over certain versions or allow a user to upgrade directly to the next minor version, you can specify metadata that allows you to do that. If you don't specify any of that metadata, then OLM has no context of how it could upgrade from one version to another, and so no upgrade will happen either manually or automatically. So I don't know if that totally answers your question. I'm happy to dig into semantics if that'd be helpful. I think it'd probably be more valuable for me to maybe link some documentation that points to like how some of that graph stuff is actually built and what some of its features are.
That'd be great if you throw it in the channel or just add it directly to the HackMD there.
Sure.
Whatever works best for you. Thank you. Any other questions or comments on this foundational stuff? All right, then let's sort of define, I think, next steps. Like, what's the process we want to follow? We did a little bit of research over the past couple months in terms of operators that exist out there, out in the world, like Tecton and whatnot, about getting those tweaked to work and to be built in such a way that they could be included in a separate catalog. What would the process look like for us to go from start to finish to get our own catalog out there? How would we break this up into steps, basically into an epic, and then break that epic into tasks, or multiple epics, as the case may be? What are we thinking?
Could we start off with an existing community operator, and then try add to that? I mean, looking at adding Tecton and GitOps and that type of thing, or I don't know, do we want to start completely from scratch?
What do folks think? So in terms of Tecton, they were making some changes to their repo for the operator, and I need to check in with them to see if those changes were made. They were moving some things around. But we could do Tecton, if we wanted to. There was, it's basically two different sections basically that went into what got deployed on OpenShift in terms of those extra tasks, the OpenShift specific tasks, and then the operator itself. So we could do that, or we could do something from scratch, or we could pick a different operator. What are folks thinking?
There is a process of installing the Tecton operator. I seem to recall that one was a bit less easy than some of the others because they created their own tooling around it, and it wasn't obvious how to extract sort of the pure operator from the tooling. I seem to recall when I tried that last time. So I think there might be easier operators to go as the first one. I mean, I had a go. I actually managed to get a catalog installed in OKD with an operator. So I actually went through the process for one operator, and I got that going. So I can share that because I wrote it up as part of the repo. But yeah, I mean, to me, I think we need to find a fairly simple standard operator that doesn't have a lot of extra caveats and just get that going, do it manually, and then work out what a pipeline would look like. Because as Kevin says, I think this is a multi-stage thing where we need to build the operator, and somehow we've got to manage the versions and how the operators sort of incrementally you progress through them. and then we pull it all together within the catalog.
I tend to agree with Brian because I seem to remember that the Tecton operator also has some kind of cyclic dependency problem. Like they're using Tecton a lot for building their own stuff. So it's a bit hard to bootstrap.
Okay, any other thoughts folks have?
Shireen, I actually think the answer to that one is yes. I think it would be quite nice if we could take something that worked on OKD and just translate it, and it will then run on OCP as
Shereen,
is.
can we back up for people that maybe aren't reading the question? Shereen, go ahead.
Do we want to maintain the same channels in the catalog as the OCP operators? That was a question.
Shereen, do you want to flesh that out a little bit?
Yeah, sure. So today in the Red Hat OCP operator catalogs, we kind of have the concept of channels, which will show us a little bit the upgrade graphs that an operator can have, and what from which version of an operator can we go to which other version of the operator. So an operator usually can have one to several channels, so making one or more possible upgrade graphs there. And my question was, when we are building our OKD catalogs, do we want to have the same channels containing the same bundles as the OCP operator?
Great. And Brian, what was your response to that?
I think yes, because say somebody is doing some work on OKD and then they want to sort of move it over to an OCP cluster. If we're in line, it means that any automation they build, any Terraform, any scripts they build around the OKD platform should work around the OCP platform. So we're just going to switch from the OKD catalog to the OCP Red Hat catalog, and hopefully it should work. If we make things very different, it means that you need to do that automation twice, which to me seems a little bit pointless, and it makes things, the interoperability between OKD and OCP, that little bit less easy.
Okay. Does anyone else have any thoughts on this?
I just like to add that in OKD, we only have 3 release streams, and you probably choose one and stay on it, which is FCOS stable, and OKD SCOS stable, and SCOS next. So there aren't that many versions to choose from, as in OCP, where you have all the release branches being supported with patch releases, patch version releases for forever, essentially. We don't have that in OKD, so we don't necessarily need to maintain different builds for the operators. If we say, look, we only have this one current OKD release, then we only build one current operator release that works on that latest OKD release, maybe latest -1. But something like that. I don't think it makes sense to create, and I'm not sure what the branches actually are, or the channels in the catalog. Are those the release branches, 4.12, 4.13, 4.14, and so forth, or are they version for the operators themselves? I'd say we have one release channel for an operator, and that is stable, and maybe another one next preview, and that would work on the current OKD release, or the current stable OKD release.
I guess if an operator has a specific requirement on a Kube API or a Kube feature, because I think some of the operators do have links to the underlying OCP version. So when you get a new version of OCP, they do increment the channel. Because I know, for example, the early Tecton and the early, pipelines and GitOps, their functionality changed between different versions of OCP.
Absolutely. The Red Hat operators do have a version dependency or requirement on the underlying OpenShift cluster. So once you upgrade, there have even been cases where customers upgrade in OpenShift clusters and then the operators stop working because there's no version available for that new OpenShift version, and the old resource, Kubernetes resources don't work anymore. So, I mean, yeah, there's just more work involved with saying, look, we have, and in OpenShift, it's mostly minor versions, so it's 4.12, 13, 14, and so forth. So the thing is, we don't maintain that same concurrent release, the same concurrent release streams in OKD. We only ever have one current, and we've recently moved to 4.13. Obviously, not everybody moves to 4.13 right away, but if we did a new operator build now, I'd say let's make it work with our current stable release. And yes, if anybody would like to backport that and build it for OKD 4.12, that operator, it's an additional build. So who's going to do it? I think if we keep it streamlined and kind of maintain the official builds, and it shouldn't be that hard to actually trigger another build if we have some Tecton task or something that does it for us, that builds the operator bundle for us, and then and that's another thing. How do you import an operator manually? You can probably you don't need the catalog. You can probably just install it, bypassing that. And I think that if you then require an operator with a newer version for your older OpenShift cluster or OKD cluster, you'll have to build it yourself. But I'd like to see the community maintain builds for the latest stable OKD version.
Jack, did you want to chime?
Yeah,
go ahead. Jack, did you want to chime in
Jack,
on anything?
Oh, well, I actually mainly just agree with what was just said. So we just have these 1 or 2 streams really. So we should just also offer that for the operators. And like, okay, if you didn't upgrade to the latest version of OKD yet, then you cannot upgrade to the latest version of that operator, and that's it. And you're gonna need to wait until you upgrade your base cluster before you can upgrade the operator if we have these requirements there. But I wouldn't like burden ourselves even more with having different streams or branches or whatever they are called exactly, because it's already now we have a very limited support policy even for the base OKD, right? That we technically only support in air quotes the current version and not the previous versions of OKD.
Yeah, I tend to agree with that. I think right now we have minimal folks involved, and the easier it is that we make it the easier the processes, the more we might attract people and eventually get people doing separate builds and whatnot. But right now it seems like just keeping up with the current releases seems like a good idea. And that's just my thought. Luigi, did you want to chime in at all?
No.
Okay.
Basically, I wrote in the chat that I agree with what Jack was saying there.
Okay.
Can I add one more question?
Sure. Yeah, Shireen, go ahead.
I'm not an expert on operator building, but I think I saw somewhere that when we build an operator bundle, it's based on the annotations that the maintainers of this operator put in the Docker file that say what the channel names are going to be and what, for example, the default channel for that operator will be. So maybe this question is for Kevin. Can we say can we do what we're trying to achieve here, which is we want to keep just a stable channel and a next channel probably for all operators, or is that something that is hard to achieve because it's the annotations back in the Git repo that kind of tell us what we can make?
So I think there's two things here. I think one is it possible with the software? The answer is yes. So I'm assuming that whatever we build here for a pipeline is probably going to use the new interface that OLM has for catalogs, which is the FBC catalogs. So anything related to channel metadata, what channels operators are in, what versions those are, is just directly editable by the FBC. So there's no reason why we couldn't just modify that data from a technical perspective. That being said, I do think we want to be quite careful with making modifications to what these operators release streams are, if we're not very confident that those upgrades are actually valid. And I say that because it is very possible in some cases for certain operators that they've defined their upgrade hierarchy specifically to solve for problems like schema migration. And if we make some heuristic and automatically modify all of these upgrade graphs automatically, I feel pretty strongly you're going to run into issues with certain operators and upgrades in certain contexts. But if we're doing the actual manual work of verifying and validating that those upgrades won't cause issues, then it's definitely possible.
Cool, thank you. That actually brings up an interesting question. We're going to have to test these as well. So we're going to have a process for not just building them, but also verifying that what we've built is actually working at a base level, in terms of these operators. So that's a whole other aspect of this that we're going to be taking on going this route. So just something to consider. What other thoughts did people
In
have?
terms of
Yeah, Christian.
if are the channels labels on the container images? Shireen, what was that? What you were saying?
Yeah, let me send you an example of a Docker file here.
I think what we could do if they're just labels, we could overwrite them, and what we could do in terms of how what stream or what branch we build for the OKD catalog, what upstream OpenShift. Unfortunately, we're still downstream builds. Ideally, we'd switch that around too and provide a build system where the OpenShift teams can actually do their own testing eventually, and then just like CentOS Stream cut their own release and put that into OpenShift and the certified catalog. Anyways, I'm going off here. I think what we want to do is once we do the switch on the OKD version from version 4.x to 4.y, we want to then also switch the branch we built the operator from, or the channel source we built the operator from. And I think we can probably solve that by adding those labels or replacing those labels, overriding them in the build process. Whether we do that locally or in a build system, we've learned that we can build the image anywhere, I think, and just push them, and we only need the reference to the image in the bundle. Yeah, so I wouldn't worry about that too much. I think we can work around these channels. Obviously, there is what Jamie just mentioned, and I think that is probably what everybody is worried about. We do need to test those upgrades between versions, whatever they may be. Cluster version A plus operator version A to cluster version B plus operator version B. So I think we do have to think about the build system for this. Yes, we can get started with locally build image artifacts, push them to a registry, make a bundle, and release that. But what I'd really like to see, and that's why the app registry thing is really cool. It includes all these things like SBOM generation, referencing all the sources. It has SNCF checking for all kinds of issues security-wise, and that is really cool in a pipeline. So I think yes, we can get started with a catalog. I don't think it's that hard to get the catalog started, but really, how do we build and maintain builds of these operators? And I think I've been working and thinking about build systems a lot. And yeah, it just becomes very clear to me that we, for operators, also need a build system that we can rely on and reproduce builds on if needed. Do all these things that that we just need to do if we want to be serious about software delivery. That's my 2 cents. Sorry about the.
I mean, is my assumption correct that we're not going to rewrite the operators? We're going to effectively use the same source, like OKD does. We're going to use the same source as the OCP. Or do we feel that we're going to have to go and clone that and then modify it? Or
that's probably going to depend on the operator, isn't it? Like if there's some weird quirk where the operator is relying on something that's not gonna just allow us to repackage and deploy it, then yeah, we would have to make tweaks. But I'm sure there are examples out there, right? But I mean, ideally, it would just be.
And what we've been doing, at least in the OpenShift organization, is we've been adding build flags, to make the OCP build and the OKD build of an artifact that's mostly within the payload, within the core OKD. But I'm sure if we were to open a PR to add a build switch to make, that community build for us, that'll be accepted in the repositories and by the teams working on this within Red Hat.
Because Kevin, question for you. I think if you look across the operators or in the current Red Hat catalog, there isn't a standard build. There isn't a standard project format. They've been built over time as the operator framework has matured. So there is differences between operators. So I think that's something that we're going to have to get to grips with.
So I think that doesn't matter necessarily, because in theory, there's only 2 things that you're actually going to need. One, which is the images, which are hopefully built somewhere else, and then the actual metadata spec, which the most trivial version of that, and what the operator framework project has been working on for a while to try to simplify, is a public interface, which is basically just a big JSON blob of all that metadata. I'm guessing that the simplest thing to do would be just commit that blob as the file that exists in Git, and then wrap that in a Docker file that's also in the repository, and then you're done. So I don't know that you necessarily need to have every project conform in the same way, as long as you can take what they have and then spit out the right JSON.
And I think that that's a really interesting point that I just hadn't thought of. Can we take the output of the Red Hat builds and use their operator bundles, or are they sort of product owned and we can't actually reuse that? That is sort of very much a Red Hat question in terms of.
I am assuming you won't be able to use those directly because they have pointers to container images that are going to be, you need a key to access.
Okay.
But what you could probably do is take the metadata from those images and then modify it so that it points to some public version of the image.
Okay.
All right, we've got about 5 minutes left. I want to narrow down to our plausible next steps. What are the next steps that we want to take? So maybe a first one might be, Brian, can you, we don't actually have a repo yet for the catalog in the new GitHub space, do we?
No, because I
Okay.
didn't know how many, what, where, and how it should be organized.
Okay, so maybe that's step one, is getting the catalog repo created, create and populate catalog repo. And we could do that based on the work that you did, Brian, unless anyone thinks we should start absolutely from scratch. But I mean, if it's got what we need, at least to get started and modify afterwards.
Well, what I'd really like is for operator builds to happen on a Kubernetes cluster. So if you could wrap your bash script or whatever you have for building the operator in a Tecton task, and run that on a kind cluster locally. And if that works, that's a grade of reproducibility that I am already pretty comfortable with. And it's something
it's really not that advanced. It's all command line at the minute.
Well,
I mean,
we can.
That's what a Tecton task is. It's really just bash in that YAML.
Do we know what the time frame is for getting on our new build infrastructure? Christian, do you have a sense of?
So it is online again. We were offline all of last week. They shut down the Operate First cluster, and our MOC cluster was also down for maintenance. It's back on now, and tomorrow Shireen and Alex are going to tackle deploying our current build pipelines for SCOS, the base OS there. I'm not sure we are at a point yet where we can use it as a service for our community members. I'd really like to do that on the secondary cluster, but that might actually, we might be able to get you your own namespace and tinker with it. We do have some limitations in terms of resources. Currently, we only have, I think, 3 nodes, and there's going to be a couple of builds for SCOS each day, but you could deploy that, I hope, starting next week on that cluster, and then later we'll move it to another build farm.
Okay,
and so it's not far out, but yeah.
Okay, Christian, why don't you work that angle? I can give Brian a cluster to work on, an OKD cluster with Tecton to work on the next week or so. If you don't have a cluster accessible, Brian,
I
can
set one up here, but before I automate it, I just need to get my head around what needs to be automated, and just really get to understand what are the artifacts we need in which Git repo, and what is the process of actually saying adding a new bundle version into the operator metadata. Is that going to be automated, or is that going to be a manual step? I just need to sort of probably sit down and just get my head around Noodle. What does an end-to-end pipeline look like? So say we've got the Tecton operator and there's the next version comes out. We need to build the operator bundle. We need to build the operator. We need to build the operator bundle. We then need to augment the catalog with that new version. And which of those steps are manual? Which of them are going to be automated? So we can then sort of work out what the pipelines need to look like. I don't have that clear in my head yet, so that's just something I've got to work through.
All right. Well, we can all.
Ideally, nothing is manual in the end.
Right.
So we do have maybe examples or templates for how this could work. I think the pipeline should include something that you would want to run on a release build. It pulls all the sources, it builds the operator, it pushes the resulting image artifact to a registry. And then you can, in Tecton, you can add, you can add the ability to not run a task or skip a task. So you can configure your pipeline with parameters that you pass to the pipeline run in order to do what you want on a local build that doesn't push the image, where you maybe already have the sources locally checked out, where you don't need to pull them, things like that. And I think a kind of a flexible pipeline that does that would be the goal, but the start would be just a task with the proper parameters to configure the task, and then it can be put into whatever pipeline you want to build out of it.
Brian, I'm happy to work with you on that. So, all right, so that's okay. I want to be mindful of time. Is there anything else that we think is should be listed in next steps between now and let's say 2 weeks when we meet again? Anything else that we should have folks tasked with?
I've got one last question for Kevin in terms of when we get all this done, what sort of security should we be looking to put within the catalog in terms of signatures or validation to sort of say that this is an official OKD catalog, to give people some sort of assurance that it comes from us, and mechanisms to say it has been tampered with? Is there that mechanism within the catalog, or is it, does that not exist, or do we just use a standard container as the SHA, the signature?
Yeah, I mean, there's nothing special about the catalog images that does anything like that. Yeah, SHA is what I would say.
Okay. Thank you.
All right. Any last thoughts before we end the meeting?
Yes, I have one question. Are you looking as a first step to build one first operator, or do you already have that and you're looking at focusing more on how to create a catalog that can serve that first operator?
I mean, I already have that. So I posted a repo in, so I've already created a catalog. Where I've come into difficulty is building the operator and then the operator bundle from the existing repos. That's what I found was not consistent, because each of the repos that I've looked at has a slightly different organization, a slightly different way of building it, slightly different tooling. So to me, the catalog bit is the easier bit. The operator and the operator bundle are the less easy bits.
Yeah. Does anyone know of basically the hello world of operators, like a real operator, but in other words, a functioning operator that has some use to OKD users, but is really straightforward in terms of its repo and its layout, that we could tweak and build, just as an example? Anyone know of a good operator that's sort of simple? Prometheus? Okay. for DNS. Okay, let me throw these in here. Let's do a little bit of research. I want to be mindful of time. I'll say look at operator examples. We can do this async. I'll put something in the group discussion, the Google discussion, and we can go from there to see which one.
External DNS operator is really a very, very small one. It has basically two images. One is the controller, the main operator, and the second is a kind of an agent, right? So it needs to build two images plus one bundle image. So and the make file that it has already has what it needs to build that. And if you look at the README, I think that it also has steps to show you how to create a small catalog just for this one operator. It's for test purposes. So the developers added these steps to show how to create a catalog so that we can test it as if it's coming in from a real Red Hat operator catalog. But it might help you to see what are the steps that are needed.
That's excellent. Thank you, Shireen. All right, let's do this async, finish this conversation, async, pick one, and then go from there. And Brian, I'll work with you on, we can hammer out issues, and if you need a cluster, I can provide it, or you can spin up your own. And all right, folks, let's take this up again in 2 weeks, because we're finally getting momentum on this topic that's really important to a lot of folks. So, all right. Thank you so much, Kevin, and all the other folks that are new attendees that have chipped in. Very important and very appreciated.
Thanks, everybody.
Thanks, guys.
Bye.
Bye-bye.